Hey, mathematicians. This activity is student book page 49, and it's called Fraction, Estimate, and Check. And this is going to be a two-part video. The first part is all about estimating what we think these fractions will be, the sum or the difference. And then the second video will be showing our actual work here and writing the actual answer in this column here. So this first video is all about the estimation, which is just as important in my opinion as the answer. Because if you can estimate accurately and if you can estimate what you think the answer will be about, then you know if your exact sum or difference comes out a lot different than your estimation, then you know something happened, either with your estimation or your exact sum or difference. So estimating any math problem really before we find the answer is really important. So the way we're going to do this is we're going to go and look at each of these problems, and I have them ready to go with the different models. So number 2, we're going to look at the clock model. Number 3, the money model. Number 4, the money model. Number 5, the clock model. And number 6, the money model. We're going to walk through each of these. So we're going to go ahead and start with number 2, 1/2 minus 5/12. And the reason why I know if I'm going to use a clock or money is when I look at the denominators, like 2 and 12, I know that both of those, 2 and 12, can both go into a clock, either twelfths or sixtieths. So I'm going to use the clock model, money model for each of these, okay? So let's go ahead. I'm going to bring this down. We're going to bring this up. Okay, so here's number 2. What I have here is the two fractions, 1/2 minus 5/12. So it's really important that we remember what operation we're using. In this case, we're using the subtraction. So I already have everything laid out here. So I have half of a clock, and I have it broken up into twelfths, but I just shaded in half. And then this clock I've shaded in 5/12, just because that's exactly what our expression is here. So 1/2 minus 5/12. So I can already visually see half of my clock here, and if I take away, remember we're subtracting, if I take away 5/12 from this half, what am I going to be close to? So what I want to do is click this clock over here, and I'm going to shade in using, I think I use this pink here. I'm going to take away these 5/12, 1, 2, 3, 4, 5 from this pink, from this yellow over here. We're going to see what we're left with. So I'm using purple. Okay, 1, 2, 3, 4, 5. So I just took the 5 from over here, and I'm taking those away from my half over on this side. What am I left with? Just left with this little sliver here, which is just 1/12 of my total clock. And that's not very big, is it? So 1/12, that's the actual answer, but 1/12 is really close to 0. It's really close to 0. So if I'm thinking about a benchmark fraction, 0, half, 1, 1.5, 2, it's closest to 0. So 1/12 is closest to 0, okay? So we'll go back and write that in a second. But number 2, we're going to write close to 0. All right, number 3, money pieces. So what I have here is 3/10 plus 4/5. So I have $1 over here out of hundredths, and I have my other dollar over here out of fifths, or we could also say tenths. So I have a tenth and a tenth. The goal is to make our denominators the same. So 4/5 is the same as 8/10 after I shade it in. So let's go back over here to the yellow one. So what I did is I broke my dollar up into tenths. That's what these straight yellow lines are. There's 10 equal pieces, and then I shaded in 3 of them. 1, 2, 3. And on this side, I have 4/5, so I cut it into fifths, and I shaded in 4 of them. 1, 2, 3, 4. And then I noticed, oh, look, when I shade in 4/5, that's the same as shading in 1, 2, 3, 4, 5, 6, 7, 8, 8/10. That makes it a lot easier to figure out how to solve my problem here. So if I take this red and I shade in if I add, because remember we're adding 3/10 plus 8/10 now, I'm going to shade in 8/10. So I can go ahead and go 1, 2, 3, 4, 5, 6, 7. Oops, look, we're at the end. So we're going to have to add another dollar. Whoops. We're going to have to add another dollar here. Can I make that smaller? No. So it'll come back here, watch. Okay, so I shaded in 7/10, and I need to shade in one more here. So there's my 8/10. So if I look at this dollar here, I'll just draw a circle. If I look at these two, this is my actual answer. And what I said was, this is really close to one whole, isn't it? Because it's one whole dollar, and it's just 1/10 of another dollar. So the benchmark, what is it closest to? It's going to be closest to 1. Okay, so it's close to 1. So let's move to the next one. All right, number 4. Number 4 is 3/4 minus 1/5. And what I did here was I have one fraction here. I have $1, that's 3/4. So I cut it into fourths, and then I shaded in 3 of them. And this one in yellow over here, I cut into fifths again, just like our last one, but I only shaded in one of them. Now, what I notice is 1/5 is 10 and 10. So 1/5 is the same as 2/20. Did you guys notice that? I mean, sorry, 20 hundredths. Let's see. Now let's say, hold on a second. I need to, whoop. Okay, so what I noticed is when I shaded this in here, I have 1/5. I have 20 shaded in, 20 hundredths shaded in. But I also have 2/10, right? Because I have a 10th and a 10th here. I also have, did you guys notice I have 4, let's see, 5/20ths, I think it is. But let's look here. So right now we're just taking what we're taking away 3/4 minus 1/5. So if I take away 21s, which just means 20. So if I take away, this is 25 over here, this section, this fourth here. So if I take away 20 of them, I'm shading these yellow because remember, I'm taking these away, and it's very subtle. But I'm left with just one strip here of 5, and then I'm left with this half up here. So my benchmark would be closest to 1/2, closest to 1/2 on number 4, because we're just left with this half up top. And then a little bit down here, but it's closer to 1/2. All right, number 5. So this one I have 12/6. So I have to have 2 clocks, because when I cut a clock into 6 equal parts, I only have 6. So I have to have 2 of them to get to 12/6. So 12/6 really equals 2 wholes, doesn't it? Now, if I take away 8/12, so I cut my clock into 12ths here, and I shaded in 8 of them. So if let's take away 8/12. So 8/12 goes to the 8 right here, doesn't it? So the 8 goes to here. So if I take away all the way to here, let's see if I can shade that in. Yeah, there we go. Purple. Okay, so let's go 2, 3. So I just took the same amount from this clock. I took that away from this clock over here. And what I'm left with is what I have in yellow. So I have 1 whole and pretty close to 1/2, huh? If this section here was the one I just had put in white was there, it would be exactly 1/2. So it's pretty close to 1 1/2. So that's why it's not really that close. It's to the 8, but it's pretty close to 1 1/2. So we're going to say number 5 is close to 1 1/2. Okay, number 6. I have 12/8 plus 3/4. So what I did here was we have 12/8, I cut those into fourths just by halving the 12/8. So if I half the 12, I get 6. If I half the 8, I get 4. So 12/8 is equivalent to 6/4. And that makes it easier for me to cut my dollars into fourths. And then I shaded in 6/4. So I cut the first dollar into fourths, shaded 1, 2, 3, 4. Shaded in my second dollar into fourths, and I shaded 5, 6. So this is the visual picture of 6/4. And this picture over here in yellow is 3/4. 1, 2, 3. If I add them together, so I need to take my yellow, yellow, and I'm going to add these 3/4 to this 6/4. So I'm going to shade in 1/4, 2/4. Oops, we have nothing else to shade, so I need another dollar. Another dollar. We'll put that right here. We'll bring back this. So what this has to do is I need to cut this into fourths and shade another one because I am at 2/4. And I need to shade in one more fourth. Okay, so this is the actual answer, isn't it? 1, 2 holes and a fourth left over. So I have 1, 2, and a fourth. And 2 and a fourth is really close to 2 holes. That's what we're trying to get at here. So 12/8 plus 3/4, which is like really saying 6/4 plus 3/4, which is 6/4 plus 3/4 is 9/4, which is equivalent to 2 and a fourth. And that's really close to 2. So what I want you to do now is we're going to come back here and we're going to write what we had in those other boxes. So 1/2 minus 5/12, that was close to 0. Write that down. So this is page 49. You're going to need this book back. So close to 0. 3/10 plus 4/5. Wish I could go back to that real quick. Let's see. So the first one was 1/2 minus 5/12, close to 0. 3/10 plus 4/5 was close to 1. Maybe I could do this. Oh boy. Sorry, everybody. Okay. So number 3 is close to 1 whole. It was close to 1. Number 4 was 3/4 minus 1/5. That one was 3/4 minus 1/5 was close to half. You guys remember that? It's close to half. Can we remove that? Yep. So we took that away. We were close to half. Okay, so number 4 is close to half. Number 5 was 12/6. This was the clock. This one was close to 1.5. Close to 1.5. That was this one. We took away 8/12 from 12/6. And then number 6 was close to 2 holes, or 2 whole dollars. Close to 2. And I'm going to go back to that real quick. That was this big one here. Okay. So that's just how you visually see these problems. I'm going to leave this here for a second. Now, in our second video, we are going to solve these problems on this page and then write the exact answer here. So this is part 1 of Fraction Estimate and Check, student book, page 49.